Here we begin 7.5, the minimum sample size problem, which is coincidentally also the name of this video, because we're going to be discussing here one of the techniques and objectives of our estimation of intervals for population parameters. Wow, that's a mouthful, isn't it? But the point is this. Let's remember what we're actually working with here. As we are making inferences about a population at large, whether that be an inference about a parameter for that population or any other characteristics, we're going to be drawing from this population samples. And from these samples, we want to be able to get a good representative picture of the population. But the question is then, if we want a confidence interval, for example, for a proportion, P, remember that we can take point estimates, but the actual proportion itself, we may never know because we're not examining the entire population. But let's say we have some specifically set, arbitrarily small margin of error, so that we say, suppose we want a margin of error no greater than whatever it could be, like maybe 0.001, 0.0001. And at a confidence level that we set, maybe that confidence level is 99%, 95%. We'll go with 99%. What sample size do we need to guarantee such a confidence interval? The idea is we're making trade-offs between convenience and accuracy. If we take a small sample, too small of a sample, it's possible that we don't capture any useful information. On the other hand, if we take an extremely large sample that's far larger than we need, we could be overestimating, blowing our budget, etc. So in the middle of this trade-off is the minimum sample size problem, which is what's the smallest n that gets us this maximum margin of error. And it is the objective of finding answers to this question that we'll do in this section and in the following video. To help motivate that, we can think about proportions or means. Well, proportions are helpful because we're usually interested in finding out what share of a population has a certain opinion about a proposition, for instance. So, for instance, in 2020, Prop 17 was passed. It was on the ballot in California, which gave or restored voting rights to people who've been convicted of felonies but had been released on parole. This ultimately passed with 59% of the vote, but the ultimate result was estimated or presumed to have been estimated by opinion polls leading up to the election. And so the question here may be, if we wanted to ensure a maximum margin of error of 1% in estimating this 59%, right? That this is P, then what's the minimum sample size that would have been necessary to make sure that our sample proportion is accurate at that confidence level? So we'll find that in the next video.